Okay, in this video I'd like to continue on and finish exercise 5A of the book Fundamental Applied Mathematics. We're on page 119 and the question is 14. Now, I think this is a very important question. If you can understand the vector usage in this question, then you are flying it. I really mean that, because it can be a bit confusing. So I'm going to read this out. It says a ball of mass m falls vertically from rest at height 4h, onto marshy ground, whose resistance is of magnitude 8 mg newtons. Find in terms of h the depth to which the ball will penetrate the marsh. So I've drawn a free body diagram there. Now I'd like you to notice something. I'm from now on going to define g, its magnitude equal 9.81, and if it's going downward I'm going to give it a negative number. Just like I really should have been doing, but for my own reasons I didn't do that up till now. So the first thing we need to do is find, using Newton's second law, the sum of the forces on the ball when the ball is in the air, air. Now those of you who are a bit switched on will realize I'm talking about the weight vector. So we're going to find that the sum of the forces on the ball is equal to the mass times gravity. Alright, and it's going to be in a j-hat direction, and it's going to be in a negative like that. Alright, because gravity is going in a negative j direction. And that's going to be equal to the weight vector. So I'm going to draw in my weight vector here. Weight is equal to negative mg j-hat. Alright, that was pretty straightforward. Now the next thing we need to do is work out the velocity at which the ball hits the ground, just like we did in question 12. So we go back to our UVAST for our accelerated linear motion, and we fill in the information we know. So we know it starts at rest and it is accelerated at a speed of, or an acceleration of g, and the distance is 4h. Now notice I'm not taking into account of directions. We know it's falling, so we know whatever velocity is going to have a negative j-hat direction. Alright, so let's just work out its magnitude. So v squared is equal to u squared plus 2as. And we're going to have v squared is equal to 0 squared plus 2g times 4h. Therefore v is equal to the square root of 8hg. So we can draw this. There's the velocity vector is equal to negative root 8hg j-hat. Alright, so its magnitude is root 8hg, its direction is in negative j-hat. Alright, so that's very important. If you understand that, you're doing very well. The next thing we need to do is to work out the overall effect of all the forces on the ball, this time when it hits the ground. So we say, use Newton's second law, the sum of the forces is equal to the mass of the ball times the acceleration of the ball. So the sum of the forces are equal to 8 mg j-hat negative mg j-hat is equal to the mass of the ball times the acceleration of the ball. Therefore, just rearrange it, and you're going to get the acceleration is 8, or it's going to be 8g j-hat. 8g j-hat. So it's going in a positive direction. So we know the acceleration, the result of all the things, is that when the ball hits the ground, its acceleration is upwards. And you need to ask yourself, does that make sense? And I'm going to say that it makes perfect sense. Because, obviously, if the acceleration was in a downward direction, then we would be accelerating the ball when it hits the ground towards the center of the earth, which would mean it would never stop. Alright, so you know, of course, I drop something, it stops. And the reason it stops is that there is a force in the opposite direction, which means the acceleration must be in the opposite direction as well. So now what we need to do is to find out how far it penetrates into the ground. So go back to our UVAST, and once again we know, of course, that it's moving in a negative j direction. It's moving downwards. So we just want to find the magnitude of the displacement, not its direction, because we know it. So the initial velocity is root 8hg. Its final is 0. Its acceleration is in the opposite direction, so I'm going to slow it down by 8g. And the distance is unknown. So let's use v squared is equal to u squared plus 2as. Now notice, of course, it's decelerating it, so that's why I have a negative number here. Alright, so 0 squared is equal to 8hg minus 16gs. So we get a distance of negative 8hg over negative 16g. It's 4h over 7. So we know, of course, the displacement, if we want to use the displacement vector, is equal to negative 4h over 7j hat. And that's correct. But you just need to remember, here we're just finding its magnitude. We already know it's penetrating into the marsh. Alright? So we know it's negative j hat in that direction. Alright? The last thing we need to do is find out, would the ball of mass 4m dropped from a height h penetrate to the same distance? And look, the short answer is it wouldn't. But just to look at this, and I'm going to do it very quickly. If you want, you can do the steps yourself. If we just want to find the velocity at which it hits the ground, well, first of all, we know the weight vector is going to be 4mg, like so. So v squared is equal to u squared plus 2as, so v squared is equal to 0 squared, and it's going to be plus 2 times g times h. So v is going to be the square root of 2gh, v prime we'll say, and it's going to be smaller than 8hg. Okay, so the velocity at which it hits is going to be smaller, and the force at which it's being decelerated isn't going to change. So this time it's going to actually penetrate to a smaller distance, and that's because the height for which it fell was smaller. So thanks for watching. Please pass it on to your friends and subscribe to my channel.